So today is topic 1.2, which is the properties of matter. So if you are absent, make sure to pause the video and answer those two bell work questions. If you're just for tutorials, feel free to skip ahead. So moving forward, after today, you'll be able to explain the following terms: physical, chemical change, and physical and chemical properties. You'll be able to differentiate between a physical and chemical change and a physical and chemical property. And you'll be able to demonstrate the difference between physical and chemical changes and properties. So what do I mean when I say property? It's a characteristic or trait that you can use to describe matter by observation or measurement. In simple terms, it's just something a substance can do. That's basically it. That's very simple terms. It's a characteristic of a substance. So how shiny it is, how strong it is, how magnetic it is, those are all properties. It's something that it can do or something that describes what it looks like. So if you're taking notes, it would be at the very top. And does deserving the property change the composition? So what it means is, if by performing the reaction, does it change what it is? If it does, that's what's known as a chemical property. So it's a chemical property, and a chemical change means that you are changing the substance. You're making a brand new substance. The big thing is you create a new substance. So that is reactivity, flammability, toxicity, and the types of bonds formed. So reactivity is how does it react with different things. Flammability means its ability to catch fire. Toxicity is how toxic it is to humans mostly, or to organisms. Types of bonds form. So we'll talk about this when we get to unit 5 and 6, and then the rest of the year. So just like you have different bonds with your family versus your school friends versus your work friend, atoms can also form different types of bonds. So those are all chemical properties. By performing any of these or observing those properties, you are changing the substance. So for example, how do you know if a chemical change has occurred? The big one, the one that will always happen every single time, is a new substance is created. So something new is made. Color change is a big example of chemical, but you have to be really careful because sometimes it can be physical. Temperature change, so for example, if it gets warmer, if it gets colder. Gas bubbles, so be careful because if something's boiling, it is a physical change because that's just the gas escaping. Bubbles are, when we talk about bubbles being formed, we're talking about the new substance that is being created, like CO2 from baking soda and vinegar. Light is produced in precipitate. So precipitate is an insoluble solid that's formed in the chemical reaction between two solutions. So precipitation just means a solid that is formed in solution. So we're looking at an example and a non-example. So looking at our example, we have baking soda, we have vinegar. So we see right here what the atoms look like and what the atoms look like. And then at the end, we have CO2 and we have water. So if you can see what the atoms look like at the beginning versus the end, they're very different. So that is our new substance. We start with baking soda and vinegar, NaHO3, and acetate right here. And we end with CO2, which is right here, and water, which is at the very bottom. So those are different substances. So this is a chemical change because you make a new substance versus a physical change. So for example, water going from a solid to a liquid. If you look, we have water molecules that are just kind of close together versus water molecules which are a little bit further apart. So again, it's still water, it's just in a slightly different shape. So if you're writing down your notes, this is what you should have so far. Going forward, so a physical property just means a property that you can look that won't change what the property is. So we have a couple of extensive properties that are physical. That means they change, which there's 3 big ones. Every single time you have mass, volume, and length. So anytime you ever hear extensive physical, there's only the 3 big ones: mass, volume, length. So those are physical properties. So it's not making a new substance. If you weigh something, it's not making a new substance as you find the space it takes out. or measuring it. Those are all physical. You're just looking at a physical property versus an intensive physical property. So again, you're not changing what it is. You're just measuring it. But this means that no matter how much or how little you have, it will never change. So for example, density. In this one, we're going to do a lab, or we've already done a lab over density, melting point and boiling point. So for example, the big one is water. So the boiling point of water is 100 degrees Celsius, no matter how much or how little water you have. Then you have specific heat. That is just the energy it takes to change or heat something up. Its color, its shininess. So for example, if you have a really shiny ring and you cut it in half, it will still be shiny. Malleability, so ability to be flattened. Ductility, ability to be drawn into a wire. Solubility, ability to dissolve. Viscosity, resistance to flow. Conductivity, so how conductive something is if a current. Hardness, like how difficult is it to break apart. And magnetism, so is it able to attract other metals. So this is what you should have so far, and then now what we're going to do is look at density as an intensive property. So density is of a pure substance, means that no matter how small it gets, you'll always be able to find the density. It's the mass divided by the volume. So density is mass divided by volume. Mass is found in grams, volume is milliliters or centimeters cubed. So, for example, your friend or your enemy has a coin that they swear is pure gold. You have doubts, so you measure the mass of the coin and find it to be 50 grams and the volume to be 1.5. And the density of gold is 19.3. Is the coin really gold? So let's solve this. Okay, so the first number I come across is 50 grams. So grams, ooh, that's pretty large, is mass. So grams is mass. So my given mass is equal to 50. The next number I see is 1.5 milliliters. Milliliters is volume, so volume is equal to 1.5. What I'm trying to find, my unknown, is density. I'm trying to calculate density. So my equation is density equals mass divided by volume. I'm looking for density. So it's going to be 50 grams divided by 1.5 milliliters equals 33.3 grams per milliliter. So if you look, if gold is 19 and the density of whatever object that your friends try to sell you is 33, that means it's not gold. There's no way it's gold. The densities don't match. So no matter how much or how little gold you have, the density will always be 19.3. So that's what I mean by density is as an intensive property. Okay, going to the next one. You're bored and want to see if a rock can float on top of water. You have all sorts of measurement tools for near a river for some reason. So you find the mass of a rock to be 6.5 grams and have a volume of 15. If the density of water is 1, what will the rock float? Sorry. So the first number I come across is 6.5 grams. So grams is mass. Next number I come across is 15 mils. Milliliters is volume. So I've been given my mass is 6.5. My volume is 15. I'm calculating density. So I don't need to rearrange my formula because what I'm solving for is by itself. So it's going to be mass divided by volume. So it's going to be 6.5 divided by 15. And you equal 0.43 grams per milliliter. So the density of water is always going to be 1. So the rock is less than 1. So therefore, the rock will float on top of the water. Now, if the rock had a density of 4.3, it would sink. So if you have any last questions over content, please feel free to reach out, send your teacher an email um, through Schoology or Gmail or so on, or just rewatch this video. Other than that, have a great day.